Good morning and welcome to our first Tech Thursday for 2023. My name is Michael Onsell. I'm the UK Sales Manager for Power Switching and Power Monitoring. I'm here joined again by my colleague, our Technical Director, Dr. Richard Gover. Good morning, Richard.
Morning. Good morning, everyone. Thank you for joining us.
Thanks for everybody for coming. First one for the year. Nice, interesting topic. Hopefully you'll get some answers out of it. And as we always say, if you've got any questions, please put them in the chat. Richard's monitoring the chat over there. We'll try to get to them at the end of the presentation. But please engage with us. If you have any questions afterwards, please also come back to us and we'll discuss them during after the Tech Thursday. So, understanding the differences between product standards, installation rules for LV Switchgear. And then, I suppose the main thing that everybody wants to know is, and who is responsible for which part. So we're going to try to break them down into a couple of different areas, product standards, codes of practice, standards, and assembly rules. So, the idea of this is, in our world, electrical is all about safety. So we're really going to focus on the life safety aspects of this because it's really important because, as Richard and I always say, we would want our families to go into a building, and I'm sure you wouldn't either, to go into a building that's not safe and doesn't have the correct life safety services.
Yeah, and I think we all see in the press there are numerous instances where safety standards haven't been adhered to, and unfortunately has resulted in the loss of life or serious injury. So it's really an important topic that everyone has a duty to understand. Thanks,
Richard. So, as we say, it's all about safety. So there's really four pieces of the puzzle here you can see on the screen. There's a product standard, there's an installation standards, there's codes of practice, and there's assembly rules. Now, one of the nuances around these sort of things is they're all interlinked and they all reference each other. So a code of practice will reference an installation standard may reference a product standard, and the assembly rule may encompass all three. So, who is responsible for which part? So the product standards, who's responsible is the manufacturer, like Socomec, and we'll give you some examples of that, and also the specifier, whether it be a consultant, whether it be an end user, they are responsible. Why? Because they need to choose the correct product for the correct application and use the correct product standard. A slight change in the product standard written somewhere can have huge impacts and implications. Installation standards, well, I think it's pretty self-explanatory, but who's responsible is the installer and or the contractor. So whether it's a contractor or any other installer, it's their responsibility to make sure that the product that's been specified and manufactured to the correct product standard is used in the correct way as per the installation standard.
Yeah, and obviously installers need to understand the product standards because they have a duty to ensure that the equipment they're installing meets the required standards. Everyone has a duty about safety.
Yeah, so we'll talk about who's responsible and what the implications are later, but obviously after a couple of incidents has happened, there's been some dramatic changes in the rules. Codes of practice is very similar to the installation standard. It's the installer, the designer and the specifier because they are normally linked to an installation standard and they need to make sure that the codes of practice will also reference a product standard and they're using the correct product. And last but not least, and that'll be the last thing we'll talk about, is how do you put an assembly together? And this is a mixture of different parts. Could be from under different product standards, from different manufacturers. And then obviously we'll talk about who's responsible for that, which is the integrator, but how you go about that. Okay, so some examples of the ones we're going to talk about today. Obviously we're going to talk about life safety because it is all about safety. So that we picked some of the main standards relevant in each section, reliant on those different areas. So product standard here, we're going to talk about 60947-6-1. Richard?
Yeah, so that's the specific standard for transfer switching equipment, TSC. It relates to that type of equipment that you're going to deploy.
Thanks, Richard. That's exactly right. An installation standard we're going to talk about is the BS-EN 12845-2015. The codes of practice, the two main ones we're going to talk about for life safety is the BS 9999-2017, which I'm sure most people are familiar with, and BS 8519-2020. And one of the things we're going to focus on as well, especially for those who weren't with us last year, but if you were, when we talked about BS 8519, is the fact that you notice that the date has changed. Okay, and that's really important because quite often we're still seeing documents come out with BS 8519 2017 referencing 2017 in BS 99, Richard.
Yeah, and 2020 saw a huge change in that standard, and I know we're going to cover it in the next few slides.
Yeah, it's extremely important.
Really important.
It is extremely important. Okay. And then the assembly rule we're going to talk about is linked to these, all of these, which is 61439-6-2. Okay. So, product standard. Here we have transfer switch. This is exactly the definition that's under this product standard, 60947-6-1. And who's responsible for that? That's on us. That's Socomec. Obviously, this is a Socomec ATS. We are the responsible party for this product adhering to the product standard.
Yeah, so we have to ensure that that product is fully tested and meets all the requirements of that standard.
That's correct. So that's our responsibility. But that's tested in this isolation, okay, in a one piece. Installation standard here is BS EN 1285 2015, and it's really around fixed firefighting systems. Now, you may think this is a bit of a strange one if you haven't heard it before, but you'll see that it's referenced in some of the other standards, especially the couple we're going to focus on in a minute. And this, once again, is really around the protection of life, which is why it's in red, and back into life safety services.
Yeah, and the protection of life is the key words there. It's all about ensuring the safety of a building and industrial plants.
Yeah, exactly. Okay. Most people would know this one, BS 9999 2017, which is the code of practice for fire safety in the design and management of and the use of buildings. So this is really around commercial buildings over 4 stories. There is obviously another standard for domestic dwellings. This code of practice is all encompassing. So even though we're going to talk about some electrical parts of it, it also pertains to lots of other parts. Firefighting lift, okay, fire systems, cables, all sorts of materials, fire rooms, even doors. Okay, doors is encompassed in this. Obviously, we come from the electrical industry, so we're going to focus on the electrical part, but it is an all-encompassing document.
Yeah, it's all about safety, and it's all about looking at the use of the building, how the building is going to be used, what the occupancy rate is going to be, and understanding what is required to make that a safe place to visit, to work in, to attend.
Yeah, and heaven forbid, if there is a situation, Richard, how people can get out of the building and be protected.
Yeah.
So, one of the things it does say in this code of practice, drilling down a bit, is that the secondary power supplies should be capable of providing power supply for items A1, A2 and A3, Richard?
Yeah, so they relate to specific items. A1 is powered smoke control. So if there is an event where smoke is going to be given off, how you can evacuate that smoke from the building.
Yep.
A2 is about fire and rescue communication. So if the fire staff have to attend the building, how they can communicate within the building. We need to maintain those communications and that equipment. And A3 is just about general firefighting equipment.
Okay, so these are all part of this. And what it says here is the key part, which is why it's in red. It must be within 15 seconds of the failure of the primary supply. So there's no need for it to go straight away. Quite often, if the second source, if you remember the picture from one of the slides further back, was on had a generator will take up to 15 seconds to obviously get up to speed and get ready to be the second source.
But obviously in that instance, it doesn't have to be a generator. You could have 2 supplies as long as they're from separate substations with a 2-hour fire rate in between them. So 15 seconds there for a generator, but you could have 2 substations.
Yeah, and which is quite often the case in data centres, because in data centres they will have 2 normally primary supplies coming from 2 different substations from 2 sections of the grid, obviously because, as we've talked before, about their maximum uptime they need. And then where it says, it actually stipulates where the power source is a generator, obviously it must have 3 hours of replenishment of fuel to allow it to run. So that is really particular in this for firefighting, because a normal generator may or may not come with 3 hours of replenishment of fuel. It may just come with an hour just as a backup somewhere else. But for firefighting, fire safety, it must have 3 hours worth of fuel. Okay, so one of the other things it says in this, which is particular in section F, is the fact that it should automatically change over from primary to the secondary power supply, because obviously in this, obviously what that's saying to you is you can't use a manual changeover switch. Now we sell manual changeover switches at Socomec like many other people do, but in this case, because it's a firefighting, fire safety, you cannot use a manual transfer switch. All right, so then it drills down to secondary power supply. These are the main items that it should be able to supply power to. And as Richard said, you've got sprinkler pumps, firefighter lifts, which we'll talk about in a minute around what's required for that, and shafts, obviously communication systems, and etc. Smoke control, as Richard said, because obviously you need exhaust fans to come on, supply fans to stop. All right.
Yeah, and obviously 9999, as we've mentioned in the previous slides, it's all about safety. It's all about ensuring the safety of a building and how people can evacuate that building in the event of an incident. So all the items you're listing there is all ensuring that's possible.
Yeah. And if you remember the slide we went back to before, one of the slides we started before, that's really the installer, the contractor, the specifier. It's their responsibility to make sure that all these services are provided with the correct equipment. Okay. And then one of the parts it also references is the life safety indicator panel. So architects don't really like them because they have a nice foyer, marble, looks beautiful, and then in the middle somewhere is a life safety services supply status, which tells them which suppliers are healthy and available, which is supplying the load. And Richard?
Yeah, and obviously you can see there you basically got 4 indicators to say whether the source is available and which is actually supplying the load. You have to provide that information. You have a lamp test button so that the firefighters can ensure that the lights are actually working. But what is key here is that has to be driven from your transfer switching equipment, your ATS. So you have to ensure that when you specify that piece of equipment, you specify the right I/O to not only drive the indicator panel, which is a requirement, but you might have requirements around BMS as well. So we have a lot of instances where this is an afterthought, and they're saying, well, hold on, we need to drive the indicator panel and the BMS. We haven't got enough I/O. So you have to understand the requirements at day one and specify it at day one.
Yeah, thanks, Richard. And it's an interesting point because I remember having a discussion with a fire lift people at an event, and it's a problem they have all the time because quite often they get there, the fire lift is the wrong fire lift, there's not enough integration, and then basically what happens is the firefighters can't come charging into the foyer, check to make sure whether they can use the firefighting lift. So this is really around the fire lift, fire safety. So when they come in, they can push the button or they can check to make sure where they've got power available, and then they know that they can actually use the fire lift to go up to the level that's required. Okay, for those that joined, we did this last year. We had a big Tech Thursday on this, which is BS 8519 2020, and really the big change in this is the date, and we'll talk about that in a minute. And it's really, once again, about life safety, firefighting and other critical. So it's fire resistant power and control cable systems, and we'll talk about that. But obviously one of the big changes, before I go into that, it's really, as before, it's for buildings for 4 stories or more. So it's like linked to BS 9999, which actually reference each other, because it's not for domestic applications, Richard. It's really for...
It's commercial buildings, and as you've said, Michael, what we're trying to understand here or get over is that all these standards and code of practice, they all interlink. So everyone has a responsibility to understand the whole picture. It's not just you as a consultant looks at one, you actually need to understand how it's going to be applied as
correct,
well.
Yes. And the contractor and the installer need to understand, and also the integrator, and we'll talk about that in a minute, really needs to understand how it all fits together. So it's identified in BS 9999, and it's changed. So unfortunately, it changed probably in the middle of the worst possible time, in the middle of COVID lockdown, but it has changed to 2020, and it's really the main point for that, Richard.
The main point, as you can see, you can't use circuit breakers anymore, and it has to be a single integrated part. So the controller and the switch has to be a single integrated part from the same manufacturer.
Yes,
it's a major change, and I'm afraid it's still not fully understood in industry.
No, and I think, we're still seeing lots of documents with BS 8519 2017, which is obviously incorrect. It's not meant to be, I'm sure it's not meant to be done incorrectly, but it is. But you need to make sure, and it's really the responsibility of whoever's writing the specification and this, and also doing the installation, to make sure that you're adhering to the current standard and the correct date. Because if you go to 2017, you'll actually be non-compliant because of the major change here, as you can see in the line here. Mm-hmm. And one of the things it says in that code of practice in 8519 is that single line bypass is a minimum.
Yeah, okay. So you need to be able to continually supply your critical load in the event of an incident if you're carrying out maintenance, which is why single line bypass is the absolute minimum. You should also consider a dual line bypass. That has a lot of benefits, such that if you were carrying out maintenance, if you were to lose your primary source, you would still have the ability to supply your critical load through source 2.
Yeah.
So the standard says single line is a minimum, but we see now a lot of consultants specifying dual line because of the added safety benefits.
Yes, correct. Yeah. So the big difference, as Richard said, is that really if you're a single line and you have the ATS for whatever reason out for maintenance, service, checking, and you're actually going around the ATS, if you lose your primary source, you're pretty much stuck. You've either got to try to somehow get the ATS back into service quickly, but in my experience, if there's a fire and the ATS is out, whoever's in front of the panel is going to hightail it out of there as quick as they can. Okay, and one of the other things you need to we take into consideration is the environment you're going to put the ATS in. So you can see, if you've got a picture here where you've got the ATS will be on the roof with the generators and all the other equipment. Okay, so it's pretty much exposed to the elements. So most of them come out, as said, are manufactured in mild steel. So some of the key things you need to really look at, and this needs to be done up front because there's no point doing it afterwards, is what the water ingress level is going to be. Okay, you've got IP55 there. What sort of material you're going to use? Make sure it's specified early. Is it going to be exposed to the sun? Not a huge problem in the UK, but sometimes it can be. We can get a bit of sun. More likely to worry about water ingress, because it does rain every now and again, especially in Wales, where Richard comes from.
Thank you.
And then the other thing is to be careful, because if your IP rating is too high, you have the risk of condensation. So you need to put mitigations in for condensation removal.
Yeah, and again, this is another area we see a lot of instances in the industry where they haven't considered the environment when they're specifying the product. And it does lead to problems, when the items are being commissioned and deployed. A mild steel ATS on the roof in a GRP enclosure is fine. You don't have to go to stainless. But it's understanding the environment, where that ATS is going to be placed, and ensure that you specify the right protection for it.
Yes.
Because I can think of numerous instances last year where that wasn't taken in.
No, and I think, and once again, it's all about safety, because if there's water ingress and it doesn't work, then the life safety service is not going to be able to work, are they? Okay, so we've talked about all the codes of practice. We've talked about, okay, you've chosen the right ATS, you've chosen the right IP rating, the right material. You know where it's going. You've got all the IO, Richard, and you've got your fire safety panel ready to go. You're all ready to hook in, okay, and now you've got to put it together. Okay, so we're going to talk about an assembly rule 61439-6-2. Now you can see from a picture here, obviously this is a Socomec one, and it's all Socomec equipment. Now that may not necessarily be the case in every installation, Richard.
No, and I think what's key there, if you look at the ATS, which is in the top right-hand section of that enclosure, it's a single piece enclosure, so that fully meets the requirements of 8519-2020.
Yes, it does. And I think one of the main things that people get confused about this around 61439 is the fact is that if each of those products conforms, and hopefully they do, to the relevant product standard, when you put them all together, doesn't mean you can extrapolate out or then assume that you will conform to 61439, because that is not the case, okay? Each one of those products are tested, like here the ATS, the changeover switches, the isolators are tested in isolation to the product standard. So it's a big area we see, and a lot of questions around about, can I give a test report or assume that the test is done because I'm using all products that are approved to the standard. So these are just obviously, in our case here, where we design our own, and the OEM is designed and tested and certified to EN 61439 because it is all of our equipment. Sorry, Sarah's got a bad cough at the back there. And these are just some of the tests. So this really is a test done when everything's together. You can't do it in isolation. It has to be done when everything's connected together, because you've got cables here, but it could be bus bars, so it needs to be tested together. You know, and these are just some of the ones. Temperature rise, okay, because obviously you put it all together in a cabinet, temperature goes up. Short circuit withstand. For ATSs, it's a very, very critical thing whether they can withstand a short circuit to allow the upstream device to do its job. Integrity, you know, it says enclosure integrity, and it's around protection and resistance, okay? But it's really also can be around where you can actually put your finger. Can the door be open when it's live, etc., etc. Okay, so it's really important to make sure that you test everything together as it is and not just in isolation, Richard.
Yeah, and obviously once you've tested that product, the installer should be asking for proof that it has been tested as an assembly. So he should be asking for the certificate of test, and then that should be forming part of the handover documentation to say, right, I've installed this equipment, it's installed to the relevant standard, the equipment I've installed has been tested appropriately. There's a documentation.
Yeah, that's very true, Richard, because really it's something we get asked for all the time. So here's an example of one of ours. Okay, it's all tested, it's certified in the laboratory. And who's responsible and where? Well, who's responsible is whoever's putting it together. Yeah. Okay, because if you're putting all the bits together, it could be a stainless steel enclosure, it could be in a different configuration, but it has to be tested, and it has to be tested by a third party. You can't test internally and issue a certificate. It must be certified and tested by a third party laboratory.
Yeah.
Okay. So, who's responsible and liable? Well, pretty much everybody in the chain, especially when it comes to buildings. Okay. The only one that gets a free pass is the manufacturer, as long as the product is certified to the correct product standard. Because here, really for fire safety, it's the employer, the owner, the landlord, the installer, and the specifier. So after, unfortunately, the incident that happened in London, which we all know about, really they've changed and tightened the rules around who's responsible. So everybody is liable, because you can't just say, well, I didn't know, because you must sign off the documents and then basically accept the building is a fire safety safe building. Or anybody else in control, facility manager. If there's a modification done, I've had a question recently where a building's been modified and they need to change the ATS bypasses, and the question was, well, do they need to conform to 2017 or 2020? It's 2020. 2017's gone. It's basically in the bin. So you have to reference the 2020. And then, for those who were with us before for BS 8519, all right, there's some pretty penalties, harsh penalties. And I think the next person that gets caught will be hung out to dry. So you've got, for those who saw before, your minor penalties can be up to £5,000, which is not short change, but major penalties can be unlimited fines and up to 2 years in prison. And I said, this is everybody in the chain.
Yeah, and I think what's key there, Michael, in the previous slides we've said who is actually responsible, but ultimately everyone is responsible about about safety. If you have anything to do with a building, the installation of the equipment, you have a duty to ensure whatever's going on in that building is safe.
That's right. Thanks for this.
There's no slopey shoulders.
No, and you can't just say do this and say, I didn't know, because you must be informed. Ignorance is not an excuse anymore.
No.
Okay, and as we always say, it's never a problem until it's a problem.
Yeah. So we have had a couple of questions come in via email, and then we've got one in the chat as well. So why is a specifier responsible for product standards?
Well, because it's their role to understand that the application of the product and what it's used for, and to make sure they specify the correct product. So in this case, we're talking about a transfer switch. Now, if you're going to do an automatic transfer switch, Richard, it has to be TSE, and it must conform to 61439-6, because that's the product standard for transfer switching equipment. Yep. So that can be a transfer switch, it can be the lift, it can be anything. but you need to know that the product stands. So a firefighting lift is different to a normal lift. I use that as an example because it's an easy one that's part of the fire safety.
Yeah. 8519 2020, you mentioned a significant change. I know we have mentioned this, but could you just clarify?
Yeah, so obviously, for those who weren't with us last year, but just coming up to speed on this, the 8519 2020, the big change is you can't use contactors or circuit breakers for life safety services. You can use whatever you need to use for electrically outside of life safety services. It can be a two-piece transfer switch and a controller, but it must be for the life safety, it must be a one-piece integrated controller, and that doesn't mean a wiring loom, because a TV and a laptop together by wiring loom is obviously not an integrated piece of equipment.
Another question, if I change the design of my assembly, do I need to retest to 61439?
Yes, you do. And that's a really good point, is that the every time you change the design, because basically you test in a certain formation and a certain combination, and then if you change that, move anything around, change the material, even if you change the material of the enclosure from mild steel to stainless steel, you need to retest, because obviously the characteristics of that assembly, which is what 61439 is completely changed.
Yeah. Another question, how often is an ATS taken out of service for ATS maintenance, and for how long to justify dual line pipe? Well,
it's a good question, and it really depends on the end user and the application, because really in some instances it might be tested every year. I can think of one example where we've got dual line bypasses are in Singapore Airport, and they're used for the baggage to come out. Now they will test those because they see that as a critical, and it's really, I suppose, beauty's in the eye of the beholder, because it really depends on what they're being used for. For most services, we see single line is completely okay. For critical applications where they have a planned maintenance schedule, then obviously a dual line just gives them the extra level of security and safety to know that if you lose your primary source power, you can change.
Yeah, okay.
It's a good question, actually.
Yeah. That's all the questions we have today. As Michael said, if you have any questions after we close, please drop us an email at info.uk@socomec.com. Please also come and see us at Data Center World, which is coming around the corner on the 8th and 9th of March. We're on stand D145, and we would very much like to welcome you on our stand, answer any questions, and go through Socomec products with you.
Yeah, and as I said, if you come and see us, both Richard and I'll be in the stand, so if you've got any more questions in relation to this or any other Tech Thursdays, just remember, if you haven't joined us for a Tech Thursday before, if you go onto the Socomec UK website, there's a link there, and you can, if you really want to watch us again, sorry about that, you can actually go there and see some of the ones we did last year, and then also we had a big Q&A one at the end of last year. But once again, we thank you again this morning for your time. We appreciate time is precious. Please engage us if you've got any questions, and hopefully we'll get to see you in the coming months at some of our other Tech Thursdays. So I wish you very best for the rest of the day. Thanks very much.
Just one thing before we go. Obviously, if you have any questions specific to this Tech Thursday, please drop us an email. But also, if you have any topic you would like us to cover, we've covered quite a number over the last year or so. But if it's a specific topic about a product or a safety standard, please drop us an email, and we'd be happy to look into it and look about doing a Tech Thursday for it.
That's a good point, Richard, because we're always happy to engage with what you want to hear about, and we'll do the research and give you an unbiased and view on what needs to be done. So thanks again and welcome. Thank you again, and good luck and have the rest of the day. Thank you.
Thank you.